Today I'm talking about summary of curve sketching. So today we discuss about how curve is sketched. We have guideline for sketching a curve. I summarized some the step for sketching a curve, but this may not absolutely right, but generally we can sketch a curve following this procedure. The first step is determine domain, and second step is find y-intersection point. Third step is find x-intercept point, and fourth step is the check the symmetry, whether it is even symmetry or odd symmetry or periodic function. Fifth step is find asymptote. We have already discussed about asymptote, horizontal asymptote, and vertical asymptote, and slanted asymptote. And the next step is increasing and decreasing test by using first derivative, and we can find local maximum and minimum extreme values by first derivative equal to 0. And next step is we have to check concavity by using second derivative. So I will take an example. The second derivative, if second derivative is positive, this is concave up, and it looks like this. When s2 prime is negative, it's concave down, looks like this. So I will take an example. Roughly sketch y equals 2x squared over x squared minus 1. So from this function, x equal plus or minus 1, at this point, the function y is not defined. We can draw this curve by using above procedure. The first procedure is we have to find domain. Domain is from minus infinity to 1, minus 1, because at x equal minus 1, the function value is not defined. And from minus 1, 1, and from 1, infinite, this is domain. And second, we have to find y-intercept. Y-intercept is x equals 0, input this function, and this is 2 multiply 0 square over 0 square minus 1. This is 0. And third step is we have to find x-interception. X-intercept, we can find the x-intercept y equals 0. Square minus 1 to x square. When in order for y to be 0, so x equals 0. So x-intercept is x equals 0. Y-intercept is y equals 0. And the next step is symmetry. You have to find symmetry. And in this case, this function is composed of x squared. This is exponent is even, so this is even function. It means this f x equal f minus x. This is even function. And next is ID test. Next step is asymptote. Asymptote 5 is find asymptote. We have horizontal and vertical asymptote. Firstly, this is long division because degree of numerator and degree of denominator is same, and we perform the long division. Long division is 2x squared divided by x squared minus 1, 2x and 2x squared, 2x. So this function y is 2x plus. No, this is 2 minus 2 and plus 2. 2 plus 2 over x squared minus 1. This is horizontal asymptote. X equal plus minus 1 is vertical asymptote. X equal plus minus 1 is vertical asymptote. and y equal 2 is horizontal asymptotes. The next step is we have to ID test, increasing and decreasing test by using y prime. Y prime is 2x squared over x squared minus 1 prime. So this can be x squared minus 1 to the 2 square, and 4x x squared minus 1 minus 2x squared multiplied 2x. It can be x squared minus 1 square, and numerator is 4x squared is cancelled and minus 4x. The critical point is x equals 0 plus minus 1, but x equals plus minus 1 is vertical asymptote, so x equals 0, and the next step is the local minimum or local maximum. So we have to determine concavity. Next step, we try to find the y2 prime. Y2 prime is minus 4x over x squared minus 1 square. This is minus x squared minus 1 to the power of 4, and 4 x squared minus 1 square minus, this is minus 4x and 2x squared minus 1, and we have the derivative at this part and the 2x. So this can be x squared minus 1 to the power of 3, and this is the power of 3, this is cancelled and this is cancelled. 4x squared minus 4 minus 2 to 4 minus 16x squared, and this is a minus, so this is a plus and minus plus, and this 12x squared plus 4. So when x equals 0 and y2 prime is negative, so when x equals 0, this function is concave down. So when x equals 0 is local maximum. So next step is we determine concavity. Concavity can be determined by y2 prime. That's the concavity, and y2 prime equal x squared minus 1 to the power of 3, 12x squared plus 4. So x squared plus 4. And y2 prime is positive when x is less than 1, minus 1, and x is greater than 1, and concave up. And y2 prime is negative and x is between minus 1 and 1. So Young is included this is local minimum. So we can draw this graph. This graph is x and y, and the vertical asymptote is minus 1 and 1. It's the vertical asymptote, and horizontal asymptote is 2. So this is the local minimum like this. And this like this. This is the answer. This is the graph, the curve of the 2x squared over x squared minus 1. The next example is the Laplace sketch y equal x squared over square root plus 1. So when x equal minus 1, the y is not defined. Minus less than minus 1 defined. So we can know the domain. Domain is x is greater than minus 1. And second is y-intercept. Y-intercept is x equals 0 and 0. X-intercept is y equals 0. and x equals 0. So 0, 0 is the intercept of x and y, x axis and y axis. The next step is symmetry, check symmetry. We cannot find no symmetry because this is a even function, this is odd function, so the mixed even and odd, we don't know the symmetry, no symmetry. And next step is asymptote, find asymptote. Asymptote is first horizontal asymptote is limit x is approaching infinite, x squared over square root x plus 1. This is infinite. This is infinite. Limit x is minus infinite, is approaching minus infinite x squared square root x plus 1. The x squared is approaching infinite faster than square root x plus 1, so this is infinite because the speed of approaching of x squared is the square power of 2, and the increasing speed of this function is x squared 1 over 2. So the power 1 over 2 is approaching infinite. The power of 2 in power of 2, this function approaching infinite. So this function is approaching infinite faster than denominator. This is 1. So this is minus infinite. This is not defined because minus infinite is less than minus 1. This is not defined. So next is vertical asymptote. Vertical asymptote is occurred and not defined. Limit x is approaching 1 plus and limit x is approaching 1 minus. This is not defined. It means x is near to minus 1, less than minus 1. If x is less than minus 1, this function is not defined. So this is x squared square root x plus 1. So this is positive and this is positive. And this is 1 over 0, so this is infinite. The vertical asymptote is also infinite. So next step is we have to find ID test. 7 and 6 is ID test. Test by using first derivative. So y prime equal x plus 1 and 2x x plus 1 square root x plus 1 minus x squared. This is x squared, and derivative of this is 1 over 2 square root x plus 1, right? So this is I write again, x plus 1 and 2x square root x plus 1 minus x squared multiply 1 over 2 square root x plus 1. So in this case, it can be 2x plus 1 square root x plus 1, 2x squared plus 2x minus x squared, means x squared plus 2x, this is the minus 2, no, this is 2x, this is 4x, so it can be 2x plus 1 square root x plus 1 and 3x squared plus 4x. A critical point is x equal minus 1. This is a vertical asymptote, and this is not local maximum, local minimum. X plus 3 over 4. A critical point is minus 1, 0, minus 4 over 3. And this is vertical asymptote, and this is not defined. Not defined because this is less than minus 1. So we have the x equals 0 is critical point, and we have to check local minimum and maximum at x equals 0. So local minimum or local maximum at x equals 0. And in order to find local minimum maximum, we check the sign change at x equals 0 or try to find the second derivative. The next step is checking concavity. We try to find second derivative. The second derivative can be 4 x plus 1 5 over 2 and 3 x squared plus 8 x plus 8 and x when y2 prime x equals 0 and positive. So at x equals 0, the curve is concave up. So x equals 0, this is a local minimum y equals 0. So next step is concavity. Check concavity. Y2 prime is positive when x is greater than minus 1. So this is concave down at x is greater than minus 1. So we can graph like this. This is x axis, this is y axis, and minus 1 is vertical asymptote, and when x is less than minus 1, the curve is not defined. So this is horizontal asymptote. This is like this, the local minimum. So this is the answer. The next example is Laplace sketch for y equal cosine x over 2 plus sine x. Sine x this is a periodic function, and since the sine x is greater than minus 1 and 1, so this is no undefined point. So domain is all real number, and second is the y-intercept. That is y x equals 0, and the 1 over 2 plus 0 and 1 over 2. And third is ID test. X-intercept. X-intercept, it can be found by using y equals 0. Y equals 0 means cosine x over 2 plus sine x. It means cosine x equals 0. Cosine x equals 0 and x equal pi over 2 plus n pi, and it's integer. So next step is symmetry. Symmetry is this function is periodic function 2 pi. So this is periodic symmetry. Although this is not symmetry, this is periodic function. The period is 2 pi. So next step is asymptote. The no asymptote, because limit x approaching infinite, y is not defined. So this not defined, and no point x is approaching something, y equal infinite. No point at this, because sine and cosine is between minus and 1. So this doesn't have asymptote. So next step is ID test. ID test can be performed by using first derivative y prime. The y prime is y prime is 2 plus sine x squared, and numerator is minus 2 sine x minus 1. The critical point is y prime equals 0, and this is sine x is minus 1 over 2. Correct? This is the the critical point. So 7 is we have to find the local minimum and maximum. Local minimum and maximum. We have to find the concavity. Next step, we use y2 prime. Y2 prime is 2 plus sine x to the power of 3, and 2 cosine x, and sine x, 2 cosine x sine x, correct? This is sine x minus 1. This is negative, and at x is, if x is 0 and 2 pi, because of the period of 2 pi, and x is 7 pi over 6, and in this region, the x is 6 pi over 7 satisfy this, or x is 11 pi over 7. Y2 prime x equals 6 pi over 7. 7 is positive. Y2 prime x is 11 pi over 7. This is negative. Pi over 7, this is negative. This is positive. No, this is y is, when y2 prime x is 6 pi over 7, 6 pi over 7, and this is negative, and this is positive, so this is positive, and y2 prime x equal 11 pi over 6, and 11 pi over 6, this is always positive, always negative. Cosine x is positive, so this is negative. So at 6 pi over 7, the graph is concave up, this is concave down. So this is local minimum, local maximum. This is local minimum. This is local maximum. And concavity, we have to find the concavity. That's A is concavity, check concavity. By using second derivative. The second derivative is y2 prime. As we before this, we try to find inflection point. Is x is pi over 2 and 3 pi over 2. The inflection point, and this is we in region between 0 and 2 pi, and 0 and x is 0 and pi over 2. This is y2 prime is negative. This is concave down. And second is when x equals pi over 2 and 3 pi over 2, the y2 prime is positive. This is concave up. And x is between 3 pi over 2 and 2 pi. The y2 prime is negative. This is concave down. So we can draw the graph. Graph is, this is x and y. The x and y and the 0. And from 0 to pi over 2 is concave down. From pi over 2 and 3 pi over 2, concave up, and from 3 pi over 2 and 2 pi and concave up. That means x equals 0, this is 1 over 2, and like this. This is inflection point. And this is changing the curve from concave up to concave down. This is pi, and this is 7 pi over 6. The value is minus square root of 3 over 3. And this is concave down and concave up. Like this. This is 2, and this is 6 pi, 11 pi over 6. This value is square root of 3 over 3. This is the answer. This is the graph. The next example is a Laplace sketch for fx is x cubic over x squared minus 1. In this case, degree of numerator is greater than denominator. We have to perform long division, and this can be x cubic is divided by x squared plus 1. This is x and x cubic plus x. So it can be x minus x over x squared plus 1. So in this case, we don't have horizontal asymptote. Instead of horizontal asymptote, we can have slanted asymptote y equal x. So we can draw a graph, the following procedure. So first, we can find domain. Domain is all region, so no undefined point at this function. So domain can be all real number. And second is y-intercept. That is y x equals 0 and 0. And third step is find x-intercept and y equals 0, and in this case x equals 0. Asymptote, we check symmetry. F minus x is equal to minus fx. So this is an odd function. So next is we have to find asymptote. Asymptote is we have horizontal asymptote and vertical asymptote. We only slanted asymptote y equal x, and limit x is approaching infinite. So y is approaching infinite. Limit x is approaching minus infinite. This is approaching minus infinite. This is not specific number. There's no horizontal asymptote. So we only have a slanted asymptote, and the next step is ID test, increasing and decreasing test by using first derivative. The first derivative is x squared plus 1 square, x squared plus 1 square, and this is 1 square and 3x squared, x squared plus 1 minus x cubic multiply 2x. This is x squared plus 1 square, and denominator is x squared, and x squared plus 3, and always positive, so into the increasing function. So this is a increasing function in all region. We don't have to check the local maximum minimum. So next step is we just concavity. We check concavity. In order to check concavity, we find y2 prime. Y2 prime is x squared plus 1 to the power of 3 and minus 2x, x minus 3. So this is the inflection point is inflection point means the point which change the shape of curve, concave up to concave down, or concave down to concave up. So x equals 0 and 3. And firstly, if x is between minus square root of 3 and 0, and x is greater than square root of 3, and f y2 prime is negative, the concave down. When x is less than minus square root of 3 and between 0 and square root of 3, the y2 prime is positive, it's concave up. So we can draw the graph. So draw this graph in. This is x-axis, and this is the y-axis. Y-axis and square root 3 and minus 3, square root 3 and square root of 3. And inflection point is 0, 0 and 3, 3 and this point, 0 and 3. x. This is this is x squared plus s square root of 3 and minus square root of 3. This is inflection point. This we have 3 inflection point. So from infinite to minus square root of 3, and this is concave up. So it's increasing and concave up like this. And when x is minus square root of 3, it changes concave up. And concave up. And x equals 0, it changes concave down. Concave down. And this is concave up. And concave down. Concave up and concave down. Concave up. Concave up and concave down. And concave up and concave down. Like this graph. And when x is square root of 3, and the asymptote is y equal x, it means this is the asymptote it means asymptote y equal x means like this. This is the asymptote y equal x. This is the answer for this question. So today we discuss about the how to sketch the curve by using first derivative and second derivative and the following procedure. Thanks for listening to this video and see you next time. Bye bye.